recording. So, what I want to do next is collect some data first, and then we'll get back to what we do with that data. Because, well, we'll say more of that later. What I've got up here, Mike, would you mind just hitting the lights? Just one of the, I think the ones closest to us. What I've got here, unfortunately, is a pretty lame video. I tried to update this yesterday using some more video capture, but I couldn't find this original video. And I'm going to find some better ones, hopefully. But this is what we're stuck with right now. It's a 50-meter freestyle competition. So these are those Evinrude guys and girls that get in the water and swim down the other end of the pool, 50 meters in less time than it takes me to go 10 in the pool. So what we're going to do is we're going to test the theory. Years ago, our old department chair, Doug Nelson, his kids were swimming at Bend High. And you remember back in the day, maybe you don't, because they're pretty young, that people actually swim on the sidelines with stopwatches. Usually parent volunteers at these swim races. And they would go, right, take your mark, set, and then they would push the button. And then the race would go on, and parents would be standing at the end, and then when the kid touched their lane, they would stop the watch, and that was the kid's recorded time. I mean, this is back in the day before touchscreens. Now everything's touchscreen. So there's a screen hanging on the other end of the pool, and the swimmer reaches up, touches that. That's what stops the clock now. So they all start at the gunshot, but then they stop when the swimmer touches the... But back in the day, it wasn't like that. Back in the day, it was the responsibility of the parent at the end to stop the stopwatch. It was. I mean, it's a high school swim competition. Or cheerleaders. Or whoever's... You, sir, street, yes, come here. Here's a dollar. So, what's interesting about this, I was talking to Doug, this is probably about almost 10 years ago now, and he said, he came in one day all in a huff. I'm like, what's up? He's like, oh my God, we had this swim parents meeting last night. The parents actually complained for half an hour about some of the parents are using their thumb, to decide to stop the watch, and some are using their index finger. And I was like, yeah? And like, we actually spent half an hour discussing both ways and how one is different than the other. It's like, are you serious? You spent 30 minutes talking about whether the thumb or finger is faster? And he said, yeah. And I'm like, why didn't you just tell me? I'll have 244 tested. And he's like, well, if I had known. So that's what we're gonna do right now. We're gonna decide, we're gonna test whether or not your thumb or your finger is faster. Okay? And we're gonna see if there's a difference. This is how we settle arguments, statistically. We're gonna see if there's a difference between your thumb and your finger. So here's what you need to, unfortunately, I'm out of stopwatches. If you don't have a stopwatch, I mentioned earlier just use your phone stopwatch, and we can try that, but the data might be different, because the stopwatch, the physiology of the stopwatch is that you have to hold it in your hand. So if you don't have one, just hang tight. If we have time, we'll do it a couple different times. So here's the deal. Let's first make sure we can take the watch, make sure you can reset it back to 0, start, stop, and reset it. I don't care what finger you use right now.
How do you turn these things on?
If it's not on, the battery's dead, unfortunately. Yeah, that battery is dead, so it's...
Okay.
Yes. And you know what's sad about the state of our economy? I buy batteries for these to reuse them. A battery for this is more expensive than the entire thing with the battery in it. Cool. And getting the batteries out of these things is no mean feat sometimes. It's very difficult. Cool. Can we start? Can we stop? Okay, here's what I want us all to do. I just realized something else we have to do before we do this experiment. We have to make sure we at least single blind it. You guys, use your dominant hand. You got a bunch of right-handers in here. Got any left-handers? Left-handers are notoriously underrepresented by the stopwatch industry. We're all right-handed, that's fine. We're all using right hands. The reason I say that is because when you hold it in your hand, if you're a right-hander, your thumb is right on the button, the start-stop button. If you want to use your thumb with your left hand, you almost have to turn it upside down so you can't see the time, which is a little bit annoying. Actually, kind of good scientifically. But anyway, we're going to decide what you're going to test first. Because I want some of you to use your index finger first, and I want some of you to use your thumb first. And I forgot to bring coins with me today. So here's what we're going to do to simulate a coin. Grab your TIs. Grab your TIs. We're going to make a coin out of our TI. $185 coin. Everybody, if you would, go to your home screen. Go to your home screen. Type your birthday in, month, day, year, 6/28/73. I don't care if you use 1973. Well, I'll use 1973. You guys put whatever you want. 6/28/73 is fine. Or you're put 19 if you want. Okay? Then type the STO button, which is right above the on button.
The what?
The STO, right above the on button, there's a store button, STO with an arrow. Right there. And then go to the math button, the PRB menu, and then press 1. So it should look like this. This might sound familiar to something you did before in my class. What are we doing right now? Anybody know what we're doing right now? Chris?
Does it matter what the digit, if the, like, OA versus...
Doesn't matter at all, as long as it's different than somebody else's. What are we doing right now? Anybody remember what we're doing right now? You're seeding the randomizer. That's why I don't care if you put 1973, 73, 1993, 93. It doesn't matter as long as yours is slightly different than somebody else's next to you. Because what we're doing is we're making the randomizer more random by putting a pseudo-random number into it to start. Is that fair? Good. Press enter. You're golden. It's not going to do anything interesting except repeat your birthday to you. That's all it does. But its job is done now. That's what we wanted it to do. Now, let's test how random it is. Let's see. Okay, you ready? Everybody press math. Go to PRB again. And go down to rand int. Select that. And type 0, 1. And then close parentheses off. Laura, what should 0 be, thumb or finger? 0 is thumb, 1 is finger. Press enter. How many zeros, i.e. thumbs, do we have? There's thumbs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the rest are fingers, yes? Let me see.
Oh, sorry, I looked up.
Okay, that's 12 thumbs. How many fingers? How'd the randomizer do, friends? Pretty damn good. It's split half and half, roughly, in the class. That's the point. The point is, if we all started the randomizer with the same random number, we'd all either get finger or thumb. If we all put the same seed in and ran the randomizer, we'd all get 0, we'd all get 1. That's kind of plain. So here's what we're going to do. We're going to try this experiment 5 times with each appendage. If you just got a 0, that's a fun word to say, appendage. If you just got a 0, you're going to do the experiment 5 times with your thumb. Then we're going to do 5 times more with your finger. Collect all that data as we go. So right now, write down what you got first. So put thumb or finger, depending on what you got. And then we're going to run the experiment 5 times. Run the experiment 5 times. Well, 10 times, I guess, totally, because we're going to do 5 for each. I'm going to turn this off because we don't need to